I'll be giving an introduction to Amazon Web Services. At least the first 1 or 2 sessions will be theoretical in nature because I want all of us to familiarize ourselves with the AWS concept, the different components involved, and gradually we'll be taking up the practical sessions as well. But for the first 1 or 2 sessions, it will be theoretical in nature. Okay. So before we go into the concept of Amazon Web Services, let's talk about cloud computing a bit. So I'm sure you are familiar with this terminology called cloud computing. It is the on-demand availability of computing resources. So when I say computing resources, I'm talking about data storage and computing power. Okay. So cloud is nothing but the internet. So all of this data storage and this computing power, you access it via the internet. So it is actually the physical hardware is present somewhere else. Okay. But you access that hardware via the internet. Okay. And so this is if you're just contrasting with the on-premise, right? On-premises, let's say the regular laptop or the desktop computer that you use, all the hardware, that is the RAM and the hard drive and everything, is present within that CPU, right? But you just compare that with the cloud computing, that RAM and hard drive is present at some sort of a remote location physically, but the internet enables you to access that. Okay. So just to draw an analogy with industry, so this is an analogy which Jeff Bezos has used to define cloud computing. Okay. Now imagine that you are running a factory which manufactures some automobiles or whatever. Okay. Now to run any sort of factory, you need power supply, right? So you will have two options. You can either build your own power plant to get enough power to run your factory, or you can go to your electricity utility provider and you can purchase power from them. So utility provider, as in you will have the Tamil Nadu Electricity Board or the Telangana State Electricity Board and so on, right? So one option is to have all the power generating capacity or the power plant close by your factory itself, which you build. The other option is to purchase the electricity from an outside vendor. Cloud computing is similar to the second option. Okay. So like I said, the actual hardware is present in data centers and you just purchase the usage of that hardware. You don't purchase that hardware, you purchase the usage of that hardware. So that is why this is called as a pay as you use model. So typically when you use a cloud computing service, you are billed on an hourly basis or a daily basis and so on. Okay. So for the duration of that you use that hardware, you are billed for it. Okay. So the main advantages of cloud computing is basically it reduces your capital cost. So capital cost is the initial expenditure that you incur in purchasing all that infrastructure, setting it up at your premises and so on. Okay, so that cost is reduced. And then the cloud computing gives you the flexibility. Okay, so imagine, so when I say flexibility, what I mean is, let's say for today's computing requirements, you require some 8 GB of RAM. Okay, tomorrow if your needs go up, you can purchase an additional 8 GB of RAM, which will bring up your total computing capacity to 16 GB of RAM. And day after tomorrow, again, if your requirements go down, again, you can scale it back down to 8 GB. So this is a flexibility which cloud computing gives you, which you cannot achieve when you have physical hardware, which is sort of fixed. There is no adjustable capacity over there. Okay. And the third thing is speed. Okay. So speed, essentially what it means is, with the given cost that you incur while purchasing hardware for yourself, right? Getting hardware which is capable of doing high-speed data processing is very, very expensive. Okay, but since cloud computing service providers operate on large scale, they have huge volumes of business. They can afford to give you that high-speed data processing capability at a very lower cost. Okay. So these are the main advantages of cloud computing. So these are the major use cases that we have today: data backup, email services, virtual desktops, virtual machines, software development and testing, big data analytics, web applications. So all of these things are hosted in the cloud. So when I say hosted in the cloud, what I mean is, let's say this typical big data analytics use case, right? So that RAM and the data storage environment, everything is present in the cloud. So okay, so any big data file that you are processing, let's say you are processing file with 1 TB of data, right? You don't have to store that file on your system. You can put it onto the cloud and then you can access it. Okay, so similarly, if you're running any machine learning algorithm, let's say if you're running it on your laptop or computer, then you will have what typically 8 GB of RAM is what you will have to process the data. Okay, but imagine you're running the same machine learning algorithm on a cloud computing platform, then you can possibly have up to or even more than 16 GB of RAM, whatever the vendor offers. Okay. So this is a brief introduction about cloud computing before we go into the actual AWS concept. So any questions, doubts?
How is it different from the server like which we use for the Unix project? We used to take some remote desktop, right? So is it somewhat similar to this, or it's like entirely different?
Yeah. So that virtual, so that's what we call as a virtual machine. So I mean, typically, I'm assuming you will use the remote desktop capability of your computer. You will specify an IP address and a password, right? That's how you connect to it, right?
Yeah, right.
Yeah. So that computer is hosted at some remote location. We don't know where that will be. Okay, and you connect to that computer via the internet, and typically that computer, if you see, it will have a higher storage and a higher RAM. So you pay just for the duration that you use that virtual machine. So if you use it for 1 hour, you pay the rate for 1 hour. If you use it for 2 hours, you pay the rate for 2 hours, and so on.
Just to add a little bit of how we have used limited. It's not like it's a lot, but I'll just tell you maybe a couple of instances where we have used. So just like what Jairam mentioned, right? So so the server that we are currently using for Inrix, so we were able to get it up and running in a matter of about a day, right? So the moment we got to know that so Swap's computer has not been able to handle, the really large file, and it was very slow. So we had a request also from the customer, the client, and immediately Swap and I looked at the situation, and so by the next meeting, he had it up and running. Okay, so how is it different? So if we were to get another laptop, for example, at the minimum, let's assume that we order from Amazon, which is probably going to be the fastest. Otherwise, we have to basically wait 2 to 3 working days at the minimum, right? Assuming, I don't know, it could be the lead time could be longer. When we last ordered, desktops for us, laptops. So the lead time was about I would say a month and a half. Okay, so from that we were able to get it down to in less than 8 hours. We were able to figure out what exactly we were looking for. The requirement was met, and Swap could actually start using it. Okay. So in addition to that, I would also like to say that at this point in time, the server that we are using, the way it works is basically we only pay for the exact number of hours we bill, okay, and it is not 100%. So for example, we only needed, I think there is a lower limit of 25% of the time. So which means that if we sort of use it for a month, for example, they will bill us at least for 25% of the time, okay, or if it is more, they will bill whatever it is on actual. And there are options where you could say, hey, I'll hire it for the entire month or for a particular time. So in the recent time, actually what happened was, so Anushri also needed it for one other project, and we turned it on. Was it Anushri or Swap for you only? It's the second project. Which was that?
Yeah, I needed that for VideoJet, and Anushri was working on Index at that same time.
Yes. So what happened was that we needed two. In fact, I think there's a possibility of a single person or two people using the same computer as well, same server as well. However, we didn't figure that out, and then we just basically said, okay, let's use another one for the time being. And we were able to quickly spin it on, and then when the requirement was off, we could just completely delete it as well. and it is like gone. We don't have any more billing on that at this point in time. Okay. So similarly, we have also been actually one of the other things that happened is, before I'm just, talking about some of the advantages. I think what we just came to know was the flexibility, but we'll also talk about certain other things that we did in the past. So some time ago, our website, because at that time it was a different scenario, cloud computing was sort of beginning to happen and so on. So we got the server, we started using it. Over a period of time, the hardware started to get slower. It was not up to the mark, etc. Right? So it's become old. Our website was on it. So at some point in time, what we did was we canceled that completely, right? And then we transitioned to a new server, which was like brand new, right? So we only had monthly recurring cost up until the time we needed it. But after that, when we needed to transition, it was not a really big cost. We just had to once again pay maybe slightly higher, probably lower, when compared to the old one, and we still get a much higher version of it to start working with. So that's the second one, second use case that I would like to give you. The third one is you look at Nextcloud, right? So our Nextcloud is also hosted on the cloud, obviously, right? And that is currently on something called DigitalOcean, okay, where most of it is Ubuntu. It's not Windows based. So similarly, you can spin it on, take automatic backup. So our Nextcloud server is also backed up automatically, and we also Nextcloud is on a sort of separate server, okay, while our website and other things are on a different server. And some time ago, I don't know if any of you noticed, our server Nextcloud stopped syncing. Okay, that's because the data got exhausted. And when that happened, I think what I did was either I was able to add additional storage space to it. That was one option I considered. The other option that I considered was that we just move, I could basically take a snapshot of the whole computer, which means that, let's say the whole server was, let's say 30 GB, all the data and everything, all of that put together is, let's assume 30 GB. So then, the whole server goes away. The whole, the content in it gets a snapshot, okay? And which means that our computing, we are not using any more computing power, which means there's no additional cost for that. There is some cost that is to store this 30 GB and it will be labeled and, it's like almost like a file name, right? And as and when we want, we can bring the exact server back to life, okay? So that option is available on, this particular this is called a DigitalOcean, but it is on Ubuntu. On Windows also it works, doesn't work, etc. It's not been as smooth, but here it's just like one or two commands, and it will just sort of put the whole thing to sleep, and the cost comes down to something like I think $0.5 per GB per month, something like that. It's very low relatively, and so it is being backed up at this point. You have to turn it. You don't have to keep the server on. And until, as and when you need it, we can bring it back. So for example, let's say we are using some of our use cases, right? So we have been, working on some analytics projects and so on. And of course, it needs some software and so on and so forth. So we can bring the whole thing up, we can do our work. And when we don't need it, we can just completely, put it down to sleep, and it goes away. It's at a minimal cost. As and when we want it, we can bring it back up with everything installed and everything. Okay, we don't have to restart the installation and everything. So these are some of the use cases that we have used. So I'm telling you not just because of this particular session, but also if we want to use it for something like this, you can also think about what to do at that time. Okay, Sai, back to you.
Thank you, Chaitanya. So now let's see what AWS is all about. So AWS is a cloud platform offered by Amazon.com. So similarly, like what Chaitanya was talking about, the DigitalOcean, Amazon Web Services is the name of the cloud platform. It's offered by Amazon. Okay. So you can contrast Amazon Web Services with Google Cloud or Microsoft Azure, which are its main competitors. And one interesting thing regarding AWS is that it is a major contributor to Amazon's profits. Okay? It's a huge line of business for them. And what AWS does is it provides servers, storage capacity, networking capabilities, remote computing, email, mobile development, and security features. Okay. So mainly, if you see, AWS has three main products. Okay. So first one is called as EC2, which is a virtual machine service provided by Amazon. And then there's something called as Glacier. It's a low-cost storage service for archiving data. So archiving data is where you have huge amounts of historical data, very old data, which you don't want to delete it. Okay, you won't be accessing that data on regular day-to-day basis, but still you don't want to delete that data. So you create a huge repository for it and put everything there. That is what is called as archiving. So this is the Glacier is a low-cost storage service for archiving. So when I say low cost, what it typically means is it will not provide that fast data processing capability. It will be a bit slow in nature, but still it is capable of storing a huge amount of data. And then there is another storage system called as S3. So these are the three main products which AWS offers. Okay. So today we'll be covering these three components of AWS. First is EC2, then S3, and then there is something called as Aurora. Okay. So I'll first talk about EC2. Okay. So EC2 is a short form for Elastic Compute Cloud. Okay. So I told you that this is a virtual machine, right? So that's basically a computing service that allows companies to run application programs. Okay. And it offers CPU and RAM. So just think of it like the desktop computer that you have. Only thing is it is hosted on Amazon's site. Okay. And developers can spin up virtual machines which provide compute capacity for IT projects. Okay. And it provides, so this is the flexibility part of it, because Amazon provides various types of instances where you can have different configurations of your CPU, memory, storage, and networking resources. So based on the configuration that you choose, based on the amount of storage capacity, the amount of RAM, the networking speed, and so on, the bandwidth and so on, you will have to pay accordingly for it. And you can increase or decrease the capacity within minutes. So the lead time involved in scaling up or scaling down your capacity is very, very short. And this virtual machine of EC2 can host the following operating system, that is Linux, Microsoft Windows, CentOS, and Debian. It also offers something called as the Amazon Cloud Watch, which monitors cloud applications and resources, allowing users to set alarms, view graphs. So you can monitor all of your AWS usage parameters. So for how long have you been using? What is the download that you have done? What is the upload that you have done? What is the speed at which the AWS processing is happening? So all those statistics you can get via the Amazon Cloud Watch feature. Okay. So this is a brief introduction to EC2. There are several types of instances that it offers. So instance, as in you can think of it as the type of virtual machine. Okay. The first is the general purpose EC2. It is designed to handle a variety of workloads, typically used for web server hosting, software development testing, the normal IT use cases. Okay. Then there is something called as the compute optimized EC2, which is to run big data applications. Okay. So this is used for scientific and financial modeling and simulation, machine learning, enterprise data warehousing, and business intelligence. And there is something called as a GPU based EC2. This is to run graphic intensive applications, typically used for gaming and 3D design, that sort of thing. And then there is another type called memory optimized, which provides ultra fast access to data to deliver high performance. So this is used for real-time analytics, open source databases, and so on. And the next type is storage optimized EC2, which is like NoSQL databases that store and retrieve data in real time. This is also used for data processing, warehousing, analytics workloads, and log processing. And Micro is a very, very basic version of EC2. This is for applications with low throughput. So this is a small database server for software testing or web server that does not require high transaction rate. So this is for very small scale use cases. So these are the different types of EC2 that are available. So this is an intro to EC2. Any questions on this concept, on the introduction to Amazon Web Services or on this Elastic Compute Cloud? Okay, so next component of Amazon Web Services is the S3. So S3 is the short form for Simple Storage Service. Okay, so this is like the name says, this is something that is used to store your data, store and retrieve your data. Okay, so all the data that you upload onto S3 is stored on the AWS platform, and you can store and retrieve data from this platform over the internet, like I mentioned before. Okay, so you just contrast EC2 and S3. EC2 is the virtual machine which provides you the computing capacity. S3 is the storage service, or so it's something like the hard drive capacity of the AWS. Okay, so it is scalable, high-speed, web-based cloud storage service. You can think of it like a giant hard drive in the cloud. That is a giant hard drive which you can access over the internet. Okay, so the way the S3 works is, you don't think of S3 like your typical SQL sort of a database. It is a file system. Okay, so you can upload files over there. The maximum size of a single file that you can upload is 5 TB. Okay, that is the size of one file. That is not the entire capacity of S3. The maximum size of one single file that you can upload to the S3 platform is 5 TB. Okay, but it can store unlimited number of files, and like I said, for the amount of space that you're using upon the platform, you will have to pay for it accordingly. And you transfer the data to S3 over the internet via APIs. That is the application programming interfaces. Okay, and the user can choose to keep the data private or make it publicly accessible. You can encrypt data prior to storage. So typically, if you see any financial applications or personal information, if you want to store that kind of data in S3, you can make it encrypted. And you can also integrate other AWS services with S3. So there is something called as Amazon Athena. This is a platform for running ad hoc queries, and there is a software called Amazon Redshift Spectrum, which is used to perform data analysis. So these services can connect to the data in S3, and you can query the data, do analysis on the data, and so on. So that is how the S3 service works. Okay.
Yeah. Sorry.
Yeah.
Could you go to So this ad hoc queries. So you told it's not similar to SQL, right? It's going to be files. So what kind of queries will we be using if it's going to be separate files?
Yeah. So that would depend on. See, for example, you have something called as a Hadoop distributed file system, or HDFS, right? So what will happen is, let's say JSON data or XML data. So for example, when I was with my previous company, right, we were in e-commerce at that time, and we had barcode scanners which we used to scan products that we put on shelves. So for example, any product, so let's say we receive an iPhone in the warehouse. Okay, so we scan a barcode which is stuck on the iPhone box. Okay, and that data is uploaded in the JSON format. Okay, and that is stored in the Hadoop distributed file system. Okay, so you can use the Hadoop query language to access that JSON data. Okay, but the query will be different. So it will not be your typical select star from query. The query will be different, but the data which is present in the form of a JSON file or an XML file, you can access via that query. So that is what I mean when I say ad hoc query source here.
Is it like a SharePoint server kind of thing where we can store data as well as files, or it's just a data source?
It is a data store. Data stored for files. So image files, text files. So whatever you store in S3 will not be in the form of tables with rows and columns. It will be a file. That file can have anything. It can have text. It can be an image. It can be whatever. But the way you access that data, you cannot use your typical SQL queries. You will have to use a different type of query.
So we can't store our actual files in it, like our Excel file with some multiple millions of records, not like that. It's a kind of data source, but a structure is different.
Yes. So think of it as a way to store your typical unstructured data that you have, right?
Yeah.
So for storing structured data, you have something else I'll be talking about in the subsequent slides. But this is a file system that you have.
Sorry, what's structured and unstructured?
So structured is data available in the form of rows and columns. Structured is your, let's say you have Twitter data, Facebook data, image data. So that is your unstructured data.
Okay, so if we can we similar to what Kapil asked, so can we simply put backup or folders something like this in this S3, like Word files and Excel files and videos, for example?
Yeah, I believe you can. I have not worked with it directly, but from what I have gleaned from my research, you can store all types of files in S3.
Yeah, that is right, Sanjay. You can just put all your files in there. So it's like, typically, what we store, right? All our files, we can have like lots of, let's say, your pictures and stuff like that, right? All your, let's say, your curriculum, old data, right? So for example, we'll generate lots of files for finance, whatever operations, so all of this. So we have lots of archive, right? For example, we work on certain, files, so we don't necessarily want to delete them. Or sometimes, you have, lots of old data. I think as you go, you will see that you are just accumulating data. You are never deleting it, right? In a way, so we can just dump all of it there. In a way.
Yeah. It's just like a spare hard drive. If you have a hard drive and you ask what kind of data I can store in a hard drive, or what can we answer there? We can put whatever the data files, etc., right? And it's just like that. It's just a cloud hardware. So we can every single file you have on your system, we can push it over to there to store it there.
Yeah, sure. Okay.
Thanks, Chaitanya and Yogesh. Yeah, so these are typical use cases: data storage, archiving. So archiving, like Chaitanya was mentioning just now, we accumulate a lot of data over many years, and we use S3 as a repository to store all of that historical data. It can also be used for application hosting, running big data analytics tools on store data. So you have all the text data, image data, and everything, and you can use the other allied services like that Amazon Athena to run queries or big data analytics on the stored data. And there is also this concept called as data lake, which is like again a huge repository of data. Typically it could be either structured data or unstructured data. Mostly data lakes are used to store unstructured data, and it can also be used to run host data, which is used for mobile applications or IoT devices. So IoT devices is that example which I was telling you about, right? Where you read data from your hardware. So that hardware could be a barcode scanner, or it could be some sensor which is constantly pushing data to the cloud. Okay, so all of this data can be stored on S3. So the next component of AWS is the Amazon Aurora. Now this is a relational database engine. So this you can contrast with your typical the Microsoft SQL Server that you have, right? So it is very similar to that. This is an SQL-based system. It is also compatible with your typical DBMS software like the MySQL or the PostgreSQL. So when I say compatible, what I mean is you can easily transfer data between the MySQL and your Amazon Aurora. Okay, so that's what I mean when I talk about compatibility. It is 5 times faster than MySQL and 3 times faster than PostgreSQL. So according to Amazon, it comes at 1/10 the cost of these commercial databases. Okay. The minimum storage space that is available is 10 GB, and you can scale it up to 128 TB. Okay. And one advantage of the Amazon Aurora is the security and the backup options or the fault tolerance options that it provides. Okay. So what it does is it divides the volume of the database into 10 GB chunks. Okay. and each chunk it replicates 6 times, and it splits these chunks across what it calls as availability zones. Okay, so availability zone is nothing but the server farm or the physical data, the building in which that data is stored. Okay, so Amazon has these server farms located at different places across the world. Okay, so these places are divided into availability zone. So whatever data you store in your Amazon Aurora, it is replicated 6 times, and it is stored across 3 different zones across the world. Okay, so the reason for doing that is, even if any one particular zone fails, so for example, in the US we recently had a hurricane, right? So that data center might have gone down, but still, since that data has been backed up in 2 other zones, your business operations or your analysis capabilities won't be impacted because you have that backup. So that's what I mentioned here. If data in one zone fails, Amazon Aurora attempts to recover data from another availability zone. Okay, and another advantage it provides is it performs automatic error scans of data blocks and disks. It ensures that data is not corrupted; it is always available. So Aurora, if you see, it is one of the most reliable database management systems that we have today. And according to Amazon's claims, it provides some 99.99% reliability. So we should say that 99.99% of the time your data will be available. There is no practically no situation that you can possibly envision where you won't have access to your data because of the fault tolerance and fail-safe capabilities that it provides. So just to contrast between S3 and Aurora, S3 is a cloud storage repository sort of thing, where Aurora is a SQL-based database. Okay, S3 is an object storage system. So you store text documents, images, audio files, video files, like I was mentioning, the JSON or the XML files. Aurora is your typical relational database management system, where you store data in the form of tables containing rows and columns. Okay, so S3, since it is a file system, it does not have anything like a schema. Okay, but Aurora is schema based. So schema is in you define that the different tables in your database, that relationship between those tables, the many to one, one to many, and so on. And then within each table, you define a particular set of columns with certain data types and everything, right? So that is what we call as the schema-based storage, and it is less flexible in nature because whatever data you put into your database has to adhere according to that particular schema that you have. Okay, but this is schema-less because it is just the file system. Okay, so S3 has only storage capability. Aurora has storage plus data processing. So data processing as in, so typically all sorts of SQL operations you can perform, right? The joining, summarizing the information in the tables, and possibly exporting the tables data into CSV format and so on. So all of that Aurora has. So S3 is less expensive, typically because it offers only the storage capability. Aurora is more expensive than S3. Okay, so that is what I had for today. The first 3 components of Amazon Web Services, which is the EC2, S3, and Aurora. So we will cover the remaining components in subsequent sessions, and then we'll gradually transition into the practical aspects of AWS. That is what I had for today's session. Any questions, clarifications?
Sai, out of just curiosity, is like Amazon's Aurora is similar to Microsoft's Azure SQL database?
So Azure, I'm not familiar.
Okay.
But yeah, it's a
SQL system, right? It's a SQL virtual machine.
Yes.
Okay.
You can use your SQL queries and access data stored in Amazon Aurora.
Okay, understood. So one of our clients actually use Microsoft Azure-based SQL system, and I think Aurora also has almost same qualities as ones that you mentioned. So I thought maybe they are like similar services from different vendors.
Right. Yes. Yeah. This is also SQL based, and you can use SQL queries here in Aurora.
Okay. Awesome.